Welcome to our countdown of 10 true facts you won't believe. Get ready to have your mind blown as we dive into the strange, surprising, and downright unbelievable realities of our world.
Alaska is unique among the United States because it holds the distinction of being the westernmost, easternmost, and northernmost state in the country, a geographical oddity tied to its location and vast expanse. Alaska is the northernmost state because it extends far into the Arctic Circle, with its northernmost point, Point Barrow, Utqiagvik, sitting at a latitude of about 71 degrees north. This location makes it closer to the North Pole than any other U.S. state. As the westernmost state, Alaska reaches farther west than Hawaii or any other state due to the Aleutian Islands chain. These islands stretch across the 180th meridian into the eastern hemisphere, placing parts of Alaska at the edge of the Western world. While it might seem counterintuitive, Alaska is also the easternmost state. This is because the Aleutian Islands cross the 180th meridian of longitude, which is the dividing line between the eastern and western hemispheres. Since longitude increases eastward from the prime meridian, 0 degrees, the islands west of the 180th meridian technically lie in the eastern hemisphere, making them the easternmost point of the United States. This combination of extremes is a testament to Alaska's vast size and unique position on the globe. With an area of over 663,000 square miles, Alaska is by far the largest U.S. state, larger than the combined size of the next three largest states, Texas, California, and Montana. Its geographic diversity and strategic position make it a fascinating region, blending Arctic tundra, coastal shores, and volcanic islands, all while holding a special place in global geography.
Canada is renowned for its abundance of freshwater lakes, holding the remarkable distinction of having more lakes than the rest of the world combined. This incredible natural feature is a result of the country's vast size, glacial history, and unique geography. Canada is home to an estimated 2 million lakes, with around 31,000 of them covering areas larger than 3 square kilometers, or 1.2 square miles. This unparalleled number of lakes is due largely to the retreat of glaciers during the last ice age. As the glaciers receded, they carved out depressions in the land, which later filled with meltwater, forming countless lakes. These glacially sculpted basins can be found across the country, from the pristine wilderness of British Columbia to the Arctic tundra. Some of the world's largest lakes are found in Canada, including the Great Lakes, which it shares with the United States, and several entirely within its borders, such as Great Bear Lake and Great Slave Lake. Great Bear Lake, located in the Northwest Territories, is the largest lake entirely within Canada and the 8th largest lake in the world. These lakes serve as critical ecosystems for wildlife, resources for human populations, and stunning destinations for recreation and tourism. Canada's lakes hold an immense amount of the world's fresh water, about 20% of the global supply. This makes the country one of the most water-rich nations on Earth, a vital resource in an era of increasing water scarcity. The abundance of lakes also plays a significant role in Canada's climate, economy, and culture, providing opportunities for fishing, transportation, and hydroelectric power generation. While many countries boast beautiful lakes, none come close to matching Canada's sheer volume. For example, countries like Finland, often nicknamed the Land of 1,000 Lakes, have significantly fewer lakes than Canada. Canada's vast and sparsely populated landmass allows for the preservation of these water bodies, ensuring that many remain pristine and relatively untouched by human activity. Canada's dominance in the world of lakes is a testament to its glacial past and vast geography, making it a global leader in freshwater resources and a haven for nature lovers.
Iceland, often referred to as the land of fire and ice, is the only country in the world without mosquitoes. This unique distinction has fascinated scientists and travelers alike, as mosquitoes are among the most widespread insects thriving in various climates worldwide. Despite Iceland's proximity to regions with large mosquito populations such as Greenland and Scandinavia, these pests have never successfully established themselves on the island. Several factors contribute to Iceland's mosquito-free status. The country's cool climate and frequent temperature fluctuations are believed to disrupt the life cycle of mosquitoes, particularly during their larval stage. Mosquitoes require stable conditions with standing water for their eggs and larvae to develop, but Iceland's volcanic terrain, glacial runoff and dynamic weather patterns limit the availability of suitable breeding grounds. Additionally, the country's water systems are often either too cold or too fast-flowing to support mosquito larvae. Another theory points to Iceland's relative isolation and stringent customs regulations, which may have prevented mosquitoes from being introduced. Unlike other countries, Iceland has no native mosquito population to adapt to its environment, and incoming mosquitoes, often hitchhiking on travellers or cargo, fail to survive the inhospitable conditions. For visitors, Iceland's lack of mosquitoes is an added perk, allowing them to explore its breathtaking landscapes without the nuisance of bites or the need for insect repellents. This unique aspect of Icelandic life is often highlighted by locals as a point of pride, adding to the allure of a country already renowned for its natural wonders.
Africa, a vast and diverse continent, holds the unique distinction of being the only continent located in all 4 hemispheres of the Earth: northern, southern, eastern and western. This geographical phenomenon is made possible by the intersection of the equator and the prime meridian, which pass through Africa and divide the planet into hemispheres. The equator traverses the continent roughly in the middle, cutting through countries such as Gabon, Congo, Uganda, Kenya and Somalia, placing parts of Africa in both the northern and southern hemispheres. Meanwhile, the prime meridian runs through Ghana, Mali and several neighbouring nations, situating portions of Africa in both the eastern and western hemispheres. This positioning makes Africa one of the most geographically diverse continents, influencing its climate, ecosystems and cultures. The continent spans a wide range of environments, from the Mediterranean climate in the north to the tropical rainforests near the equator and down to the arid deserts and savannas of the south. Africa's geographic spread across all hemispheres contributes to this variety, as the equator creates equatorial zones of high biodiversity, while the division by the prime meridian emphasizes the continent's global centrality. The fact that Africa lies in all 4 hemispheres also enhances its significance in global geopolitics and trade. Historically, this central location has made Africa a crossroads for civilizations, facilitating the exchange of goods, ideas, and cultural practices. Today, it underscores Africa's strategic importance in connecting different parts of the world. The continent's hemispherical placement also means that it experiences both equatorial and temperate climatic influences, shaping diverse agricultural systems and ways of life. Africa's hemispheric uniqueness is not just a geographical fact. It symbolizes the continent's central role in the Earth's interconnected systems. From influencing global climate patterns to its position as a hub for biodiversity and human culture, Africa's location across all 4 hemispheres is a remarkable testament to its pivotal place in the world.
Mount Everest, standing at a staggering height of 8,848.86 meters, which is 29,031.7 feet, is a symbol of natural grandeur and an ever-changing geological marvel. Its continued growth at an average rate of about 4 millimeters per year is a direct result of tectonic forces that have been shaping the region for tens of millions of years. This growth is tied to the collision of the Indian and Eurasian tectonic plates, a process that began around 50 million years ago when the Indian plate began its northward movement, eventually crashing into the Eurasian plate. This collision caused the Earth's crust to crumple, fold and thrust upward, forming the Himalayan mountain range, with Mount Everest as its crown jewel. The ongoing growth of Mount Everest is not uniform but rather part of a complex interplay of forces. The tectonic push from the Indian plate is the primary driver, forcing the Himalayan region upward. However, natural forces such as erosion from wind, rain, and glacial activity act to counterbalance this upward movement. These erosive processes gradually wear down the peaks, demonstrating a delicate balance between growth and decay. Despite this, the uplift caused by tectonic activity has remained slightly dominant over millions of years, allowing Mount Everest to retain its position as the highest peak on Earth. Modern technology has revolutionized our ability to measure and understand the growth of Mount Everest. Using tools such as global positioning system devices, satellite imagery, and sophisticated laser scanning, scientists can now track minute changes in the mountain's height with extraordinary precision. For example, during a 2020 survey, Nepal and China jointly measured the peak's height, incorporating advanced techniques to ensure accuracy. Such measurements not only confirm Everest's annual growth, but also provide critical data for understanding the dynamics of Earth's crust in this region. Interestingly, Mount Everest's growth is not always steady. Sudden, dramatic events like earthquakes can cause temporary changes in the mountain's height and structure. For instance, the devastating Gorkha earthquake that struck Nepal in 2015 caused a slight subsidence in the surrounding region, with some areas sinking while others rose. Although Mount Everest itself was largely unaffected in terms of height, this event highlighted how seismic activity can reshape the region in an instant. In the long term, however, the tectonic forces responsible for the mountain's growth tend to overshadow these episodic disruptions. Mount Everest's ongoing rise serves as a reminder of the dynamic nature of Earth's surface. It is a living testament to the immense power of plate tectonics, a process that continues to shape not only the Himalayas, but also the landscapes of our entire planet. As scientific research and monitoring techniques advance, our understanding of Mount Everest's growth and its connection to Earth's broader geological systems will continue to deepen, offering valuable insights into the forces that sculpt our world.
The Dead Sea, a unique hypersaline lake located at the lowest point on Earth's surface, is renowned for its extraordinary buoyancy, allowing people to float effortlessly on its surface. This phenomenon occurs because the Dead Sea's salinity is exceptionally high, about 34%, nearly 10 times saltier than most oceans. The elevated salt content significantly increases the water's density, making it easier for the human body to stay afloat without any effort. This natural buoyancy is one of the key reasons the Dead Sea attracts visitors from around the world. The high salinity of the Dead Sea is the result of its unique geographical and climatic conditions. Situated in a desert region, the lake receives minimal rainfall and has no outlets for its water to flow into other bodies. Instead, water entering the Dead Sea from its main tributary, the Jordan River, and occasional rainfall only leaves through evaporation. The intense heat of the region accelerates evaporation, leaving behind high concentrations of salts and minerals. Over time, this process has created one of the saltiest bodies of water on Earth. The water of the Dead Sea is rich in various minerals, including magnesium, potassium and calcium chloride, which not only contribute to its salinity but also provide therapeutic properties. The mineral-rich mud and water are believed to have healing benefits, making the Dead Sea a popular destination for wellness tourism. Its environment has been used to treat skin conditions such as psoriasis and eczema, as well as to promote relaxation and skin rejuvenation. Floating in the Dead Sea is a surreal experience, but the extreme salinity also comes with some caveats. The water can be harsh on the skin and eyes, causing irritation if splashed into the face or if there are any cuts or abrasions. Furthermore, drinking the water or prolonged exposure can be harmful due to its mineral composition. Despite these precautions, the Dead Sea remains a sought-after location for its unparalleled natural phenomenon. Interestingly, the Dead Sea is shrinking at an alarming rate due to human activity and climate change. Diversion of water from the Jordan River for agricultural and industrial use has significantly reduced the inflow into the lake, causing its water levels to drop by over a metre per year. This has led to environmental concerns and efforts to mitigate its decline, such as projects to bring water from the Red Sea to replenish the Dead Sea. Whether such efforts will be sufficient to preserve this natural wonder remains uncertain. The Dead Sea's unique ability to allow people to float effortlessly, combined with its mineral-rich composition and striking desert landscape, makes it one of the most fascinating natural landmarks in the world. It stands as a testament to the diverse and extreme conditions that can exist on our planet, providing both recreational and scientific value.
The statement that Russia is bigger than Pluto is a fascinating comparison that underscores the sheer size of the Earth's largest country and the relatively small size of this distant dwarf planet. Russia spans an incredible 17.1 million square kilometers, making it the largest country on Earth by land area. It covers roughly 1/8 of the planet's total landmass, stretching across 11 time zones and encompassing a diverse range of landscapes, including tundra, forests, mountains, and plains. Pluto, on the other hand, is a celestial body that was once considered the 9th planet in our solar system, but was reclassified as a dwarf planet in 2006 by the International Astronomical Union. Its total surface area is estimated to be about 16.7 million square kilometers, which is slightly smaller than Russia's land area. This surprising fact highlights the diminutive size of Pluto, despite it being a significant object in the Kuiper Belt, a region of icy bodies beyond Neptune. The comparison is intriguing because it challenges common perceptions about planetary bodies. While Pluto might be imagined as enormous due to its planetary status in popular culture, its small size becomes apparent when measured against familiar earthly landmarks like Russia. This discrepancy arises from the fact that celestial bodies vary greatly in size, and not all planets or dwarf planets are comparable to Earth in scale. Russia's vast size contributes to its geopolitical and cultural significance. The country is home to a wide array of natural resources, ecosystems and climates, which have played a critical role in its history and economy. Its landmass includes Siberia, one of the most expansive and resource-rich regions on the planet, further emphasizing its global importance. Pluto, while smaller, is equally fascinating for entirely different reasons. Its surface features include vast plains of nitrogen ice, towering water ice mountains, and a thin atmosphere composed primarily of nitrogen with traces of methane and carbon monoxide. Pluto's exploration has been limited, but the 2015 flyby by NASA's New Horizons spacecraft provided humanity with the first detailed images and data of this distant world, revealing its complex geology and surprising activity. In comparing the two, the scale disparity between terrestrial and extraterrestrial objects is striking. While Russia's size is tangible and observable, Pluto's smaller size is part of its charm and mystery as an enigmatic member of our solar system. Together they serve as a reminder of the vast differences in scale and perspective between our home planet and the universe beyond.
Antarctica, the southernmost continent on Earth, is often associated with its icy expanse and extreme cold, but it is also classified as a desert. This designation might seem counterintuitive given its thick layers of ice and snow, but it aligns with the scientific definition of a desert, a region that receives very little precipitation. Antarctica receives an average of only about 50 millimeters or 2 inches of precipitation per year, mostly in the form of snow. This is less than the Sahara Desert, which averages about 76 millimeters or 3 inches annually. The low precipitation in Antarctica is due to its extreme cold and the behavior of atmospheric moisture. Cold air holds far less moisture than warm air, and the frigid temperatures over Antarctica prevent significant amounts of water vapor from accumulating in the atmosphere. As a result, snowfall, the primary form of precipitation in Antarctica, is sparse. Additionally, much of the continent is shielded by high-pressure systems that further inhibit the formation of clouds and precipitation. Despite being covered in ice, Antarctica's conditions are strikingly similar to those of a traditional desert. Most of its surface is dominated by permanent ice sheets that have accumulated over millions of years. However, there are regions of the continent such as the McMurdo Dry Valleys, where the landscape is completely devoid of ice and snow. These areas are among the driest places on Earth, with some spots receiving no measurable precipitation for thousands of years. The classification of Antarctica as a desert highlights the unique interplay of cold and dryness. While its landscape appears vastly different from hot deserts like the Sahara, they share the defining feature of aridity. Interestingly, the Sahara, with its scorching temperatures and sand dunes, experiences occasional rainfall and even rare flooding events, which are almost non-existent in Antarctica's interior regions. Antarctica's desert status has profound implications for its ecosystem and research potential. The harsh conditions make it one of the most inhospitable places for life, with only specialized microorganisms, hardy lichens, and a few invertebrates managing to survive in the ice-free zones. However, the continent's dry and stable environment is ideal for scientific studies, such as drilling ice cores that provide insights into Earth's climatic history over hundreds of thousands of years. The juxtaposition of ice and desert in Antarctica serves as a reminder of Earth's incredible diversity and the adaptability of the natural world. It challenges traditional notions of what a desert looks like, demonstrating that aridity can manifest in both blistering heat and freezing cold.
The Amazon River, one of the most iconic and mighty rivers on Earth, has a fascinating geological history that includes flowing in the opposite direction millions of years ago. Today, the Amazon flows eastward across South America, emptying into the Atlantic Ocean. However, evidence from geological and fossil records indicates that during the Mesozoic era, around 100 million years ago, the river once flowed westward toward the Pacific Ocean. This reversal in the Amazon River's flow is closely tied to the dramatic geological changes that shaped the South American continent. At that time, South America was still connected to Africa as part of the supercontinent Gondwana. The Andes Mountains, which now form a massive natural barrier along the western edge of the continent, had not yet formed. Without the Andes, the continent's topography sloped gently westward, and rivers, including the early Amazon, drained toward the Pacific. The rise of the Andes, which began about 65 million years ago due to the collision of tectonic plates, profoundly altered the continent's geography. As these mountains rose, they created a massive physical barrier that blocked the Amazon's westward flow. This blockage caused water to accumulate and form vast inland seas and swamps, effectively reversing the flow of rivers in the region. Over millions of years, as the Andes continued to grow and the landscape adjusted, the Amazon River found a new path eastward towards the Atlantic Ocean, which remains its current course. The reversal of the Amazon's flow had profound effects on South America's ecosystems and biodiversity. The transformation of the river's direction and the subsequent drainage of the inland seas reshaped the continent's habitats, influencing the evolution of its flora and fauna. Today, the Amazon River and its basin are home to the most diverse ecosystems on the planet, including the Amazon rainforest, which owes its existence in part to these ancient geological shifts. Evidence for this ancient reversal comes from sedimentary deposits and fossil records. Geologists have identified sediments along the Amazon's current course that were once deposited by rivers flowing in the opposite direction. Additionally, fossils of marine organisms have been found in regions that are now far inland, providing clues about the ancient inland seas that formed during the river's transitional period. The story of the Amazon River's reversed flow is a testament to the dynamic nature of Earth's surface and the powerful forces of plate tectonics. It illustrates how geological processes over millions of years can reshape continents, redirect massive rivers, and create entirely new ecosystems. This history adds another layer of intrigue to the Amazon River, a natural wonder already celebrated for its scale, complexity, and ecological significance.
Point Nemo, a remote location in the South Pacific Ocean, holds the distinction of being the most isolated spot on Earth. Officially known as the oceanic pole of inaccessibility, it is located at a point that is farthest from any landmass. The nearest land to Point Nemo is over 2,688 kilometers, or about 1,450 nautical miles away. To put this distance into perspective, the International Space Station, orbiting Earth at an altitude of approximately 400 kilometers, or 250 miles, is often closer to Point Nemo than any human-inhabited land. Point Nemo is named after Captain Nemo, the famous submarine captain from Jules Verne's novel 20,000 Leagues Under the Sea. It was identified in 1992 by survey engineer Hervoge Lucatella using computer modeling to pinpoint the exact location. Point Nemo lies in the South Pacific Gyre, a vast expanse of open ocean known for its relative lack of marine life and scarce human activity due to its remoteness and nutrient-poor waters. The region surrounding Point Nemo is so isolated that it is often called an oceanic desert. Few species inhabit this area, as the lack of nutrient-rich currents makes it difficult for marine ecosystems to thrive. The absence of human activity also means that the waters here are largely untouched, making Point Nemo one of the least polluted areas of the world's oceans. Point Nemo has another intriguing association. It is often referred to as the spacecraft cemetery. This is because it is the designated location for controlled re-entries of decommissioned spacecraft and satellites. Its remoteness makes it an ideal crash site, minimizing the risk of debris causing harm to humans or property. Since 1971, more than 260 spacecraft, including parts of the Russian Mir space station, have been intentionally deorbited to splash down near Point Nemo. Despite its isolation, Point Nemo has captured the imagination of adventurers, scientists, and storytellers. It serves as a powerful symbol of Earth's vastness and the limits of human exploration. Its location, far from human civilization, also underscores the interconnectedness of Earth and space, as the ISS orbiting above represents humanity's presence beyond the planet, while Point Nemo below remains one of the least touched places on Earth. Point Nemo is a fascinating example of how geography and technology intersect to reveal the planet's extremes. Its status as the most remote location on Earth highlights the scale of our planet and the sheer expanse of the oceans that cover more than 70% of its surface.
Thank you for watching. We hope these mind-blowing facts left you amazed and inspired. Don't forget to like, subscribe and hit that notification bell because there's plenty more where that came from. Stay curious and we'll see you in the next one.